Okay, good morning, everybody. My name is Neil Proctor, and you're at the developer track with the user authentication session. But now that I've got a microphone in my hand, I can't promise that some karaoke won't slip in there. All right, so before we get started, I want to thank you for joining us at the 11th Annual Denver Startup Week. These Startup Weeks are fantastic. I get to meet so many people, have so much fun. And thank you to our title sponsors, Amazon, Capital One Cafe, Dell for Startups, and the Downtown Denver Partnership. This session is part of the developer track sponsored by Quizlet, one of 8 programming tracks aimed at supporting the entire entrepreneurial team. That means everybody. And by attending this session, you're agreeing to follow our code of conduct, so no screaming at me, as well as agreeing to being photographed and recorded on video. And please be sure to share this experience online using the hashtag DenStartupWeek. And if you're feeling spicy, hashtag passwordless. All right. So, like I said earlier, I'm Neil Proctor. I'm the founder and CEO of Vault Vision, a Denver startup focused on a better, safer, more secure login for your users. We're members of both the FIDO Alliance and the OpenID Foundation. Now, this doesn't necessarily make me an expert, but it does my checkbook. Just kidding, my checkbook can't even do crypto. So, I've been in the industry for 25 years, working on everything from robotic semiconductor automation to backup software for the government, to domain names and hosting. And in that time, the most problematic issue that I've had to solve in just about every project is passwords, auth, secret management, key management. And I'll tell you a story. When I started with GoDaddy way back in the early 2000s, when you would register a domain name, we would ask you to give us a username and password to manage just that domain. And when you went to check out and give us your credit card, we'd again ask you for another username and password just for your billing information. And then guess what? When you wanted to set up your email, what did we do? Asked you for another username and password. And then when it's time for your hosting, we again asked you for another username and password. And by the time you wanted to set up privacy on that domain, we asked you for a record 5th username and password. So all of that just to get a business up and running with a website and an email. So that's really where my passion for eliminating passwords was launched. Now back then, it was workable because it was understandable and it fell in lines with the concepts of where a user already wanted to delegate authorization. So it was nice because you could just hand over that hosting password to your web designer and not have to worry about them getting into your email or your billing. But that worked then, but now we've got things that are much, much better. Okay, so the best presenting advice I've ever heard is to tell them what you want to tell them. So here's what I want to tell you. There's 3 takeaways. The first is that good auth is hard, and as an industry, we've got to do a lot better. There's constant news reports of breaches, and every single, maybe not every single one of them, but most of them, the key breach was because of some mismanagement of credentials. The second is that passwords are vulnerable and too risky. They're too risky to use anymore. There's better technology out there, and that's, I am assuming, why you're here today. So I want everybody to get on board the pass key train. Now these pass keys are these FIDO devices, plus I'll tell you about what Apple has recently done. So with iOS 16, Apple has effectively made every iPhone equivalent to one of these hardware security keys. So that's the big deal. And even Brian Krebs, a renowned cybersecurity pundit and journalist, agrees with this. He says, shifting to a real FIDO-based auth is the only sane move. And this tweet came right after the Uber breach. Okay, so hopefully this is why you're here. You're smart folks, you recognize the problem. I don't have to tell you twice that there's better options out there. And I'm really excited to share this new FIDO technology that can literally defeat phishing. It's way more convenient for the user, and it's super secure. And in fact, if you are a big fan of passwords, by the end of this session, you'll probably be offended. Now, I'm just kidding. I'm going to offend you right away. All right. Okay, so good auth is hard. Why do I say this? And I say this because the industry has done just a terrible job at it. And auth shouldn't be underestimated. If your company or if your application team doesn't have the resources or the expertise to deal with it, that's okay. You can still get good auth. Just hire it out. Use a service. Use a provider. But make sure you get that expert because the industry demands it, your customers demand it. And just about every company that I've ever dealt with has had some kind of breach, all tracing back to, like I said earlier, credential mismanagement. Additionally, I can't tell you how many login screens that I audit where I see third-party JavaScripts included from third-party domains, specifically Google Tag Manager. So literally, when I see that, it's just like someone's decidedly opening themselves to JavaScript injection by their marketing teams. So that's not very good. All right, and the other reason this is good auth is so hard is because, as you can see, there is an absurd amount of combinations of technologies and environments and user expectation. Even Apple, who's probably the best at it in the industry, has done a pretty good job. But I'll tell you what, I still have old iTunes accounts I can't get into. I still have old iPads that I can't get into because they've changed the re-verification process. And with this last bullet, this is really the big one. The industry at large has had a really tough time coming to consensus on the best way to solve this. Now, this is where FIDO is so great, because the big three, and I'll talk about this in a little bit, the big three have agreed to do this. And this is crazy, because in an industry where we can't even get consensus on what the minimum password length should be, we now have consensus on a architecture to remove passwords. So that's fantastic. And regarding the password lengths, it's weird because I've seen minimum length requirements of 5, 6, 8, and 10, maybe 15, or maybe 14, but you never see an 11 or a 9. So somehow we've agreed it can't be 11 or 9. All right, so when it comes to specs for auth, there's quite a few out there. As you can see, it's a tremendous body of knowledge, but this is literally what it takes to do auth better. Now, I won't say this is what it takes to do it right, because I'm sure 5 years down the line, the landscape will be totally different. The COVID chips from the vaccine will start kicking in, and we'll all be this mindless hive of logging inners, so that'll largely probably be solved by that. But the nice thing is, because of all these specs, there's a bunch of great open source libraries that do all of the heavy spec construction, spec compliance for you, especially if you're using a common language or a platform like .NET or Node or Go. So all it leaves up to you is to just understand these interfaces and to plug into them. Okay, so what's new? Why have this talk at all? And this is probably why you're here. You want to hear what is new in the industry, what's the key events and milestones that make this worthwhile to talk about. First off, we've got a whole bunch of players, key players. They've anteed up and they've renewed their importance and dedication to strong auth. Everybody wants to get rid of passwords as much as I do. In fact, I often say that's my second title, the eliminator of passwords. And speaking of that first bullet, a tremendous amount of different vendors now produce these FIDO keys. Apple's got it built into the iPhone. There's about 5 or 6 ones that do the hardware. And there's also software vendors that will do this, as well as vendors that will bake it into badge access cards. So this is not only a badge access for a door in physical security, but it contains in here another FIDO chip so that you can use the same device for both physical access and workstation desktop access. And if you think about it, for the first time, this is the first time both keys and locks can be made by different companies. If you take, for instance, your car or your house keys, you can't just go down to Home Depot, and if Home Depot is out of the blank for your particular vendor, you're out of luck. You can't use another key blank from another vendor. But luckily, the big three have agreed on this. They can't even agree on playing nice with text messages, but at least we got them to agree on this. Now this is pretty recent though. You can see Apple only joined the FIDO initiative in February 2020. Now this was so revolutionary and it was so good that the world actually had to stop and give us COVID right after. All right, but the middle one is the one I keep wanting to focus on. So as of this month, iOS 16 makes it possible for your iPhone to be one of these. So you can go to a website that supports FIDO now and use the built-in passkey function on the iPhone and log in without a password. And that's in everybody's pocket. So previously, one of the blockers to a large FIDO rollout was the fact that not everybody has these. Not everybody's ponied up the $20 or the $20 per employee to roll this out to your whole company. But now, literally half the market has it. Google has something similar, but Apple's actually backs up to iCloud. So that was the other big blocker of a large rollout. So people would always ask me, well, what happens if I lose it? And I would say, well, I hope you registered too. So now you don't have to worry about that with the iPhone and with iOS 16. Okay, so let's do a little bit more overview on these FIDO tokens. What makes them great? Why is this shift so important? Well, the whole shift to FIDO is based on a couple of important security concepts. First is that, in case anybody can't see these, there's a larger picture of, on the slide. But first is that the secret, the private key, only gets created and lives within this device boundary. All right, so when that secret gets created and registered, the secret doesn't have to leave the device. The secret never goes into the OS, never goes into the OS's memory. It stays here. And during the authentication process, the authenticating server will send a challenge to this device. This device will do the crypto on the chip, or in the Apple's case, in that protected passkey. Maybe it's the TPM on the iPhone, but it'll do it outside the realm of the OS, so this device can protect that password, or that passkey. So there's a big difference in thinking of those secrets as passkeys rather than passwords. And the fact that they're totally protected in a encapsulated environment, that's the big shift. That's how we get away from using a password that in order to use, we actually have to reveal and expose. All right, and that's really how we defeat phishing, because you no longer have to reveal your password. Okay, so let's take a deeper look at the components. Everybody in here is probably a developer or an app builder, and you want to see how does this actually work. So first things first, you can see the password down below is gone. The user is clearly happy about it. That's a big smile. And I think they're dancing, but this isn't TikTok, so I can't really tell. Now, the other big thing to point out is the password's no longer there, but the passkey now lives on the FIDO authenticator. And again, these FIDO authenticators can be built into a platform like the iPhone, like Android, like the Windows Hello devices. That's one of the reasons that Microsoft has mandated for Windows 11 that your device has to have a TPM, a trusted platform module, so that it can store these secrets outside of the OS. Store them on something that's not on disk and doesn't ever get revealed into OS memory. Okay, so there's a couple of different protocols at work here. There's one called the CTAP, that is the Client to Authenticator Protocol. That's what the browser speaks to this device. the browser or the platform in the case of an iPhone or mobile device. And then there's the app code that runs client-side. So this is the JavaScript that you'll run in the browser. That'll speak a protocol that's most important, WebAuthn. So if you're an app developer, an app builder, that's what you're going to be researching. That's what you're going to be looking into, figuring out how your app can plug in to all of the WebAuthn specs. And I don't want this to be overly complicated on the authenticator side. That's what these vendors have already figured out, is the communication between the browser and the authenticator. So that's something we should know about, but it isn't anything you're going to necessarily have to dig into when you're doing any of this application development. Now, the other interesting piece to take away from this component slide is that the public keys is stored on the auth server, and that goes all the way to communicate to the FIDO authenticator, and that's how that authentication really happens, is between that public and private key encryption. And for anybody that wants to have a really good analogy for when you're telling your friends what's the big deal about public-private key encryption, it's similar to the U.S. Mint. When the U.S. Mint creates a $100 bill, they put in, 8 to 10 anti-counterfeit controls in that bill. Now, the way they do that is very private. That's their private key. But they're very public about what those controls are, so that when you get past that 100, you can hold it up to the light, you can see the watermark, you can see the plastic anti-counterfeit strip, but they make that very, very public. And it's the same sort of paradigm. There's a private key, but a public key can be used to ensure the authenticity of the response that was signed with that private key. Okay, so for a little bit more detail, we'll look into this flow. This is an example flow of a FIDO login. Again, the whole point of this is to give a landscape view. All of these details isn't that important. The biggest takeaway I'll show in a second is that there isn't a whole lot of complexity here like there is with running an e-commerce shop. So just ordering a t-shirt off an e-commerce, you're dealing with billing, payments, refunds, you're dealing with different sizes, you're dealing with how do you integrate with Stripe, how do you integrate with shipping labels, all of that. There's a ton of complexity for something as simple as selling a t-shirt. But with this, it's manageable. You can get it all on one slide, and you can see the important components in one overview. But really, we've got our happy user. They want to log in. They start the flow at the authentication server, and this is where the data flow starts, because that authentication server is the one that knows which user is logging in and which private keys that user has already associated to their account when they first registered. Now, this is a big difference in the auth model from passwords. So right now, a user can only have one password. In the FIDO model, you can have as many authenticators as you want tied to one account. And in fact, right now, that's how they recommend you back up, is that you register multiple FIDO authenticators, which is great if you want to have a quick and dirty delegation. Maybe you and a partner need access to the same one account. You can each register your own FIDO token. Maybe some of you are founders and you've got 5 other co-founders and you all need access to the same one account. Each could register their own token. And even for remote work, whenever you onboard a new employee or a new contributor, previously somebody in your user admin group would probably, or maybe it was you, you'd probably set them up with an account and you'd email them a password. Well, that's no bueno, because we don't want to keep passwords in email, and you don't want to upset the apple cart, specifically me, by doing that. So now you can have them register their own FIDO token. That can be saved in a pending state, and then when you're ready, as a user admin, you can just associate that credential with that user. And they never have to exchange what that password is or what that secret is. So it's great for remote workers there. All right, now when this request makes it to the authenticator through your JavaScript, through the browser, and down to the actual device, the authenticator will then match it up to all of the credentials that it knows about from the relying party. So there's some overarching checks in place to make sure that the privacy and the integrity of these public keys and private keys aren't leaked. So one of the big concerns is that you wouldn't want any rogue website to be able to read all of the credentials or know about which credentials I've stored for which sites. So that's built into this overarching control. Okay, now when the request does get to the authenticator, you can see that there is a prompt back to the user for consent. So this little device will actually confirm with the user at the platform level so that it can't be blocked or interrupted or masked. It'll ask, hey, did you actually mean to log in? And you literally have to tap or do some sort of gesture on the device, or if you've set a PIN, you'll have to enter that PIN. But this is really, really an important feature of this FIDO technology, because this prevents any malware, or let's say you installed a malicious browser and that browser wanted access to your E-Trade and it just started to try to log you in automatically, you would get these prompts at the platform level. So it's not like that malware can then stop that prompt. So that's an important way to not only defeat phishing, but to defeat any rogue processes that's running on your device. Okay, so once the authenticator is able to match up that private key to the public key, it signs a response and then sends it back. It includes a little bit of data about the client that it just authenticated, plus a little bit of data about the authenticator itself. It's got some authentication counts and some other interesting properties about the authenticator that the OAUTH server can then choose to care about or not. And then, of course, that will be returned back to the OAUTH server from the client-side code. Now, I just wanted to give a little bit of an example to, again, illustrate that this isn't a hugely complex idea. The ideas basically come down to protect that secret and then do the authentication through some simple public key, private key signing. So up at the top, you can see the request payload. Maybe you can't see it because it's very, very small. But take my word for it, that upper left payload includes the allowed credentials. That's just a simple list of the public keys that have been registered. And that gets passed into a call, navigator.credentials.get. Again, fairly simple call. This is a standard API now built into all the browsers. And that's really the WebAuthn spec. So we're not talking about massive Stripe. If everybody's ever integrated with Stripe, whenever you do any call there, you get these massive JSON documents that you got to parse all kinds of information out. No, these are very bite-sized, very chewable. And at the bottom is the response. Again, you can see it contains a signature, a little bit of JSON about the client, and some JSON about the actual authenticator itself. Now, I'll warn you, some of these are encoded differently. The device actually wants byte arrays. It doesn't want strings. So this abstracts that a little bit, but reading the spec, you can find a ton of libraries online that already do this. And then again, to validate it, you just pass that right back, and there's built-in libraries for JWTs that will validate that signature for you, and away you go. And again, the sign-up is roughly about the same flow. It just changes a little bit of the payload, and instead of calling a get, it calls a create. Okay, so this is all super great. Everybody loves FIDO. Yay, FIDO. All right, let's get rid of passwords. But still, you know, that seems a lot of work. What about OAuth? What about OIDC? And this is the real workload that will enable you to really take advantage of this, is because Google's already done this, Apple's already done this, companies like Vault Vision, my company, has already done this, and you can use what's called OAuth and specifically OIDC to integrate with these providers so that you get all of this great security, all of this great convenience. You get to come up and say, my product doesn't need a password, my competitors do, suckers, and to do that, you can use OAuth 2 and OIDC. So OAuth 2, I'm not going to go into a ton of detail, but it's a way to distribute authorization. I'm going to use a really bad analogy, so forgive me, but a normal authorization flow, if you want a drink as a resource, you go to the bartender, you present your ID, your credential, the bartender gives you that ID back. Now, if anybody's ever been to a nightclub, you know that that won't scale. So you need some way to distribute that authorization, hence the bouncer. So the bartender is super happy because he no longer has to deal, he or she or they, with any of these angry people that don't have their IDs, but their stomachs, their client app, so to speak, that wants that drink, still complains and wants that resource. Well, now the bartender can simply forward that to the bouncer. That is now the bouncer's problem. And that's the analogy that I want to make with all of this authentication is be that client app, be that bartender, send these problems to the bouncer. Use a service, use a provider, use an expert. Somebody's already done that. Use this technology, OAuth 2 and OIDC, to help solve that. Now, OIDC is OpenID Connect. This is the technology that layers identity management over OAuth 2. So OAuth 2 is really designed to only delegate authorization and not identity, hence OIDC or OpenID Connect that layers over the top of OAuth 2 a way to not only get authorization, but identity through an identity token, an ID token. And with OpenIDC, there's, again, a lot of providers, a lot of open source libraries. This is how you can enable a sign in with Google button on your app very easily, is by registering an application with an OIDC provider. And to register it, Google or somebody like myself or somebody like Microsoft, when you register your client or your application to be able to provide this delegated auth through their identity systems, you'll need to tell them what your name is, the name of your app, your website, some terms of service, a privacy policy, so that they can present that in a consent screen when the user is going through that first initial authentication flow. They'll know exactly who they're giving that access to, as well as you'll need to register what scopes, what you want that access for. And for OIDC, usually you're just going to want email, OpenID, and profile as your scopes. If you're diving deeper into some of the resources of those APIs, maybe you want access to those as well. But the main takeaway is that in order to integrate with an OpenID Connect provider, you really only have to do three things in your app. There's really three URL endpoints that are important. There's the login URL. So this is the endpoint that you tell the provider about where to send users if it doesn't know that a login flow is initiated. So one of the hardest things about OIDC Connect is that you can't just give a endpoints, or you can't just give a web page of the provider as a login link. You actually have to generate a login link in your app and then 302 the user to that login link. And you, in that login link is a callback URL. That's the second item. So one of the key mistakes that people do when implementing OIDC is those callback URLs have to be exactly. They have to be an exact match. There's a ton of times where I'm helping implementers and they have things like trailing slashes, they have HTTP versus HTTPS. Those things can't be there. They have to be an exact match. You can't fuzz any of those. And then thirdly, you just have to implement a logout or a, on the application side, when you implement the callback URL, that's the URL endpoint that the user will be returned to after they auth. And then you can use the standard libraries to pull off those token sets, validate them, and then create a session. And then last, all you need to do is have some sort of logout URL where you can do any session cleanup if you need to. Now that last one's not important, but it is nice if you have to do some post-logout cleanup. So again, the main takeaway is that if you can implement two endpoints in your app an endpoint that can generate a 302 for a login, and an endpoint that can receive a 302 with some query string parameters. And if you can register these in a provider, you can get all these benefits of passwordless auth, seamless auth for your users, super secure. You can defeat phishing. You can give a double bird to Uber and say, haha, we're better. And that's it. I'll insult Uber at the last. No, just kidding, Uber, we love you. I use you all the time. Okay, I think we're at the end of our time. Any questions? Yes.
So in the first example, with just using without using OpenIDC, if we had an e-commerce store, we wanted all of our users to, they're going to have, if they're on the browser, they're going to have one of those keys.
So they're either going to have one of these keys, or like I mentioned, Apple with iOS 16 has literally turned the iPhone into one of these keys.
But if I'm not on the iPhone, I'm on my browser, on my Mac, which that's Apple too.
Sure. They do have it on the Mac with Mac OS Ventura. That's the latest one. So let's say you're on whatever platform you're on. If it's in the browser, Chrome is a platform, and Chrome also, I believe, Chrome will now, if you have a TPM, Chrome itself will allow that FIDO authentication to happen, and Chrome will become the platform that then stores it in the TPM of the device.
Okay. So if I'm just a dumb user and I go to log in, my computer is actually providing the FIDO stuff.
Your computer, yep, your platform.
Is it going to pop up with a little pop-up saying, hey, is this you?
Absolutely. It'll.
Talking about the confirmation with the device.
Absolutely. So that's part of the spec, part of the FIDO spec, is that in order to have that authentication happen, there has to be that consent from the user. So there'll be some sort of password, or there'll be some sort of prompt, and most of the time a user will have set a PIN. PIN's much easier to...
You have to set something up first, I guess, in the very beginning.
Nope. The first registration, it will ask you if you want to put a PIN. You don't have to put a PIN, but the authentication for when it lives on the device, and specifically in the case of Chrome, it'll live in the TPM, or in the case of the iPhone, it'll live in that special TPM that's included in the hardware.
Because on Mac, we don't use Chrome, but on the iPhone, we can just use Safari.
Sure. So Safari supports this as well. Yep. Okay.
It's safe to say that basically what's happening is there's a public key that's presented of sorts on the client side, correct? And then Google or whatever the identity provider is has a corresponding private key that's representing you, and that's how they're resolving that, yeah?
Yes, to be really specific, the Google side, the service side, has the public key, and the private key only lives with you on your device, your FIDO token. That private key never leaves your TPM, and it never leaves, if you use a roaming authenticator, it never leaves this. But the service you're authenticating with, the Googles, the Microsofts, the Twitters of the world, they'll store your public key, which is fine because it's made to be public. It's like that US Mint. It's that list of anti-counterfeit controls that's allowed to be and is supposed to be available to everybody.
Yeah, but wouldn't they have to verify the signature on my private key though too somehow?
So that's with the crypto. That's, again, that whole US Mint analogy. By the private key doing some cryptography, it's able to sign that signature, and using those public instructions, the service can then verify that, yes, indeed, it was only that private key, only that US Mint that made that $100 bill.
So every time the user switches a device, you're going to store that private key on that device. And he's going to say, they're going to prompt him, hey, it's a system.
So there's a little bit of a new development effort that's occurring in that regard. So if you use a roaming device, these will be available for anywhere. But if you're using the platform device, the thing that's built into your motherboard or your mobile device, there's a new effort that these three are going to support, which is a multi-device FIDO, that there'll be a way where you can take one device, either take a picture of a QR code, maybe enable Bluetooth on both, and it'll have a way of automatically syncing that. that passkey to another device. Yep, so you can have eventually, and this will probably come out within the next year, but this is the big multi-device, but Apple will automatically do this through their sync to iCloud. Yeah, but eventually you'll be able to sync that to a Windows laptop, a Google Android.
Apple syncing it now.
Apple is syncing it now to your iCloud in iOS 16.
If I log in from the iPhone and then I log in from my Mac, it'll just go to the iCloud again.
Yep.
And is Apple like register all the iCloud accounts then?
So when you first do this on your Apple device, it'll ask you to enable this iCloud syncing. So it won't automatically, steal your passkeys. You have to turn on specifically passkey syncing to iCloud. Yep.
What's your opinion on less
Sorry.
sophisticated two-factor authentication, like email or text, some other device that is it's not quite as cryptographically secure, but what are your thoughts on that as a halfway measure?
It's better than not, but time and time have showed that it's still vulnerable to social engineering. And in fact, on one of the What's New, earlier in 2021, President Biden issued an executive order called Improving Our Nation's Cybersecurity. And in that order, in very, very strong language, they out and out say you can no longer do that. You must have something that's entirely phishing resistant. So yeah, it's going to be good for maybe the next 2 to 3 years. But again, just like Brian Krebs mentioned, let's go all in. Let's get rid of passwords. Let's get rid of the multi-factor. I have tons of stories I can tell you about people that didn't know you can't just take a screenshot of a link and send it to somebody who is asking because they're going to win some prize. And that's how they defeat and social engineer over multi-factor all the time. Yeah.
So if you go where you just have this physical token, is that, you're kind of back to one-factor auth, right? Somebody can just, like, what's not someone can just physically stealing the token that's like sitting on my desk in my apartment right now?
Sure. So there's two things. One, you can put a PIN embedded on these. And then second, those authentication servers can still add as many factors as they want. So you can still get rid of the password. You could use this, but if you want, you can absolutely do another multi-factor. It could be another one-time password that you send through your typical MFA authenticator now. There's no reason you couldn't layer on as many as you wanted.
Do you expect places are still going to do a password and then also just use the token as a factor?
So there's a lot of places that do that now, but for me, I don't see a use for that. Like, let's use the token, get rid of passwords completely, and then multi-factor, there's probably better AI ways you can detect who's logging in with what, that you don't need the multi-factor.
Can you also revoke the token? If say gets stolen, you can report that, and the token can be revoked by the...
Absolutely. You can just remove the fact that that public key is assigned to that user, and that effectively revokes the token.
Is the request for a PIN controlled by the identity provider or by the token itself?
By the token itself. Yep, so that is a token-specific thing. If I plug this in to 5 different computers, it's only the PIN that's stored on here. Doesn't matter about the 5 different computers. Yep, in the back.
What were the other two endpoints, the callback endpoints? You mentioned the login one.
So there's the login endpoint where you need to use that to initiate the login flow for OIDC. Then there's the callback URL. So once you initiate that login flow and that user authenticates at that identity provider, they're going to send that user back. They're going to 302 the user back to some callback URL that you've registered. And in that callback URL, you just have to peel off the parameters that will contain that token set and then use a library to extract the information out of that token set. And then the third one is optional. It's a post-logout return to. So if you need to do something to destroy sessions or to reset anything in your application and you want to get a notification after a logout's happened, that's how you can do it.
So to follow up on the second one, so can you spoof the scopes?
You cannot spoof the scopes. Well, what do you mean by spoof the scopes? So this is all going over TLS. Now, it's included in your request what scopes you want. And if those don't match what you've previously requested and been approved for, then that flow won't work. So the scopes that you're requesting at runtime have to match the scopes that you've already got approved for when you registered your client or your application. Yes?
What do you see as kind of like the time frame for widespread adoption for this? Because I mean, like, listening to this right now, I know a bunch of people that could do it. My parents, who can barely operate a phone,
Sure.
would be able to do that, and they wouldn't trust it because they know that they wouldn't understand like the underlying mechanics of it. Just be like, well, I know a password to save because I typed in my password. Like, how do you convert those people, and what's kind of the time frame you guys see as the wider adoption for this?
Sure. So I think, as I mentioned earlier, it's right now. It's literally this month. This month with Apple's release of iOS 16 and the fact that now half of the people already have a way to solve what were those major barriers, it's just going to happen lickety-split. I mean, that's what I'm banking on. I build a company that enables this and wants to accelerate this and help you, the app builders, the app developers, have to not worry about that. We'll be the bouncer. You just be the bartender.
Actually getting a little more afield, but so you have a unit in the iPhone, like you mentioned a bunch of times. It's great that it's a separate module, but like we all know hardware bugs happen. There's been any number of CPU-based leaks and things like that. So, like, what's to prevent that from happening? Like, I get with the physical, the existing UD keys, like when I'm done with it, I physically unplug it from my computer.
Sure.
I'm pretty sure it's safe, but once it's in the machine, it seems like there's a much bigger attack surface there.
So the reason that the attack surface is lessened is because the TPMs are specifically designed to never reveal the secret. There's no API where you can get the secret out of the TPM. It's a one-way thing. The secret's created in that chip and then never leaked out of the chip. Even if you get malware on that device, there's literally no way. Or if you want that secret back out, sorry, you can't. It's locked in there. So there's no way to get that chip to tell you it's secret. You can't torture it, you can't fake it, you can't bribe it, you can't malware it, you can't install new apps on the TPM, you can't install new apps here that could be malicious. It's locked in there. Well, so I mean, if you go to DEF CON, they'll present this huge way where they've opened the phone and soldered in things and made ways to get it out. But for most people, that's way too much effort to get a secret out. But yeah, everything's got vulnerabilities.
Yeah, I mean, I guess I'm a little skeptical because like there was like Spectre and Meltdown and all the various like CPU sniffing things that were not supposed to be possible, and then it turned out they were possible later.
Well, so with the Spectre and those pre-execution things, those were performance enhancements where they were trying to, they weren't security enhancements, right? This is very specifically a security chip whose sole function is to not rat you out. Yep, there's no API to do it. Even physically, it's very, very difficult. They're actually certified. All right, any other questions? Well, this has been great. I love getting all of these questions. Everybody's super engaged. Way to go. Keep up that energy. Go Denver Startup Week. All right, thank you very much.